In this video, we're going to talk about the domain of an algebraic expression. First, a definition. The set of real numbers for which an algebraic expression is defined is the domain of the expression. We further say that two algebraic expressions are equivalent if they have the same domain and give the same values for all numbers in their domain. So for example, we could go through and look at x plus 1 plus x plus 2. If we were to add these two polynomials together, we would get 2x plus 3. What this means is that these are actually equivalent algebraic expressions, okay? We haven't talked about domain yet, so it's not clear that they actually have the same domain, but we'll talk about that momentarily. Now, before we proceed, it's important to remember what an algebraic expression involves. Namely, it involves constants and variables that are combined using addition, subtraction, multiplication, division, exponents, and we saw, so before our list only came up to exponents, but we saw that radicals can be written as rational exponents, so we'll go ahead and remind ourselves that radicals can also be included. As such, when it comes to the domain, there's really sort of two things to look out for here that could go wrong. The first thing is division by 0. And the other thing to look out for is even roots of negatives. Negative numbers. And the reason why is that both of these are bad. Okay? For example, let's go ahead and find the domain of each of the following expressions. For this one, we can ask ourselves, does anything really go wrong here? And the answer is, well, there's no place where we divide by 0. There's no chance of dividing by 0 because there's no division. And there's no even roots going on here, so there's no chance of taking an even root of a negative number. So because of that, we say, well, all numbers should be included. So that is, our domain is all real numbers. Here we have an even root, namely a square root, and so what we know is that x minus 2 must be greater than or equal to 0, because we can't have it be negative. In other words, we have that it's all real numbers greater than or equal to 2. For this one, we see that we could be dividing by 0 if the denominator were equal to 0. So what if x minus 3 were equal to 0? And really, that's bad. That's what we don't want. So let's go ahead and say that x minus 3 does not equal 0. That means that we can't have x equal to 3. So this would be all real numbers for its domain not equal to 3. Or you might say except 3. And now it's time for you to try an example. So go ahead and find the domain of each of the following algebraic expressions. On the count of 3, I'll reveal the answer. 1, 2, 3. So for the first example, while nothing goes wrong here, we actually have a domain prescribed for us, so we have to use that. Namely, we have all real numbers greater than or equal to 0. On this problem, again, we have x plus 7 must be greater than or equal to 0 because of the even root. And so we get all real numbers greater than or equal to negative 7. And then finally, x cannot be 0, so it's all real numbers except 0. For more practice involving figuring out the domain, go ahead and look at page A42 of the textbook, numbers 1 and 5 through 16. In our next video, we'll be talking about simplifying rational expressions.